Here's one of the hardest concepts in biology explained.
So today we'll be looking at pedigrees. In this question, we've got 1, 2, 3, 4 pedigrees, and then we're going to be classifying them in regards to autosomal or if they're sex-linked, pretty much. Alright, now looking at this first pedigree, we can see an unaffected daughter, which is represented by the white circle, coming from 2 affected parents. Now, if we use a Punnett square, where capital R is the dominant gene, let's say RR and RR, okay, if we draw a Punnett square, looking at all the possibilities, you'll see there's a 25% chance of it not being affected. So that does make sense that can be possible. So we can eliminate the ones that are not autosomal dominant. For 2, it's the opposite way around. We've got affected children from unaffected parents. Now, how would that be possible? Well, assuming that the parents are both carriers of this recessive gene, this is going to be autosomal recessive dominance. So again, same thing. And if you do the crossing over, you'll notice that the lowercase r also represents the affected children. So it's the same sort of method for both. Now looking at number 3, this is definitely going to be sex-linked, and we just got to classify which one. When you see there's more daughters than sons that are affected in this case, this refers to sex-linked and specifically this dominant type, okay? Looking at the 4th pedigree, we've got sons that are affected, right? This refers to sex-linked recessive. Now let's explain why this is the case. We know sons have the XY chromosome where the Y is pretty much useless. So they can only display the X chromosome, meaning they have an increased chance of displaying that recessive gene. Whereas daughters, on the other hand, have a X and X chromosome. This means they're more likely to be affected as they'll still be a carrier of that gene.